Hey, this is Math 7, Unit 8, Lesson 2, Chance Experiments. And the key word here today is chance. All right? So we're going to investigate chance today. So first of all, we have two questions here, two situations. Which one do you think is more likely to happen? When reaching into a dark closet and pulling out one shoe from a pile of 20 pairs of shoes, you pull out a left shoe. So here you have like a closet, right? And you have 20 pairs of shoes. You have shoe, 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 right? You could draw yourself your pairs of shoes if you wanted to, but there's 20 of them. Again, I don't know if I have time to draw 20, but imagine that. And you reach in and you grab one of the left shoes there. Or is it more likely that when listening to a playlist which has 5 songs on it, that when it's in shuffle mode, the first song on the playlist plays first? Well, let's think about what the kind of chances are going to be for this. Now again, nothing is ever certain, but we're talking about what is more likely to happen, not what is certain. There is a difference there. Certain means it's 100% chance of happening, right? That means no matter what, it's gonna happen. So with these things here, it's never 100% chance, but which one is the most likely to happen? So if I have a closet full of shoes, I have left shoes and I have right shoes for every pair of shoes. Now, that means if I have 20 pairs of shoes, I have one left and one right, which means that there are 20 lefts and there are 20 rights. So if I reach in and just grab any random shoe, what's the chance of me picking a left one compared to a right one? Well, I have a 1, actually in this case I have a 20 out of 40 chance, or 20 out of 40 chance, or a 1 out of every 2 chance of that happening there, don't I? Right? So basically it's like 50-50. It could happen. There's about a 50% chance that I can pull out a left shoe, because every other shoe is one's left, one's right, how it works. With the songs though, I have a 1 out of 5 chance for the first song to come up on the playlist, which means there are 4 chances for it to not happen, right? So 4 non-options over there. A lot more chances for it to not happen than for it to actually happen. Whereas over here, I had a 1 out of 2, right? So it's most likely going to happen. Now, is it certain? Again, nothing is certain. But the one that's the most likely of the 2 choices would be this one. You see, a 1 out of 5 chance, if you think about it as a fraction, is 1 out of 5. If you did that division, you'd come up with 0.20, which as a percentage is 20%. So as we're talking about this and kind of thinking about prior lessons, this has about a 50% chance of happening, and this has about a 20% chance of happening. So this one is the more likely to actually occur. All right? So in the next lesson, we're looking at how to label events with options such as impossible, unlikely, equally likely as not, likely, or certain. Okay, so that's kind of the idea. So the idea here is think about a book, a book you might have. I'm looking around my shelf to see if I have a book I can pull out real quick. I don't know. Here we go. Here it is. Youth Soccer Drills. Alright, so this book has a total of, look at this here, it has 214 pages. Nice old book, pulled off the old shelf. 214 pages, right? So this book has 214 pages. Now, what are the odds that, if we're talking about impossible, if I just turn any random page, I find page number negative 34. Do you think I can flip to any page and find page negative 34 in this book? Probably not, right? That is impossible. Okay, what if I said if I randomly open the book, I would select page number, let's see, anywhere between page number 1 and, I don't know, 10, right? 1 and 10. Randomly, I throw the book into the air, or someone like grabs it, and whatever finger they land on is what they open it up, right? I go, oh, nope, that's page 134. Nope, that's page 59. I don't know. So that's unlikely. So it has a very small chance. What if I said, okay, I'm going to open this book up and I'm going to land on a page somewhere between page number 1 and 120? Well, that's equally likely as not, right? It's about halfway through. If I said I'm going to land on pages numbers 1 through 200, that's likely going to happen there. And if I just said I'm going to land on any page between 1 and 214, that's for sure. I'm going to get one of those pages there. So the more chances something has of happening, the more likely that is actually going to be. So when I look at these options here, And again, you could differ on some of them, that's okay. You will win the grand prize in a raffle if you purchase 2 out of the 100 tickets. Now, that's a pretty small percentage, right? That's about 2% of that. So is it impossible? No, it's possible. You could win, but it's most likely unlikely, right? We would probably say it's unlikely to happen 2 out of 100. That you'll wait less than 10 minutes in a fast food restaurant. Well, it's called fast food for a reason, so you'd hope it's not more than 10 minutes. So for this one here, I would probably say it's likely. And again, these are ones you can do ahead of time and think through it. You will get an even number when you roll a standard number cube. Well, the number cubes have what numbers? 1, 2, 3, 4, 5, terrible 5, and 6. So we have even, even, even. And we also have odd, 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 but that means that half of them are even and half of them are odd. So in terms of the likelihood, we would say equally likely as not. It's a weird phrase, I know, but that's what we say. A 4-year-old child is over 6 feet tall. Now this is one where for sure it's unlikely, right? Is there a chance that some 4-year-old just grows to 6 feet suddenly? I guess it could happen. It's probably most likely impossible, but it's not totally impossible. But if you want to go with unlikely, awesome. If you want to go with impossible, both would be fine. The chances are really, really, really small that ever happens. That if you see a 4-year-old who's 6 feet tall, that would be an issue. All right. E, no one in your class will be late to class next week. Now this one really depends on your class, okay, and the school you're at. You probably could look around the room and decide, oh, nope, I know that person over there is late every other day, so probably not. So to have no one in your class late to class, that's going to depend upon your class most likely. For no one to be late to class at my school, if I think about the whole school, I would say that is unlikely. Now, is it impossible? No, it's not impossible, but it's unlikely. There's usually someone who, had to make one more text message to a friend or one more conversation in the hallway. So someone tends to be a little bit late. Okay, what are the chances of the next baby born at the hospital being a boy? Well, your options for being born are generally boy and girl, which means it's a 1 out of 2 chance, so about 50-50. So we would say equally likely as not, right? About an even chance of having a boy or a girl in terms of how that works out. All right, let's look at G in the next page, same idea. What are the odds that it will snow at our school on July 1st? Now, depends on where you live. As I've watched kind of people that follow this video channel and stuff, we have people up in Alaska and Maine and states like that. So maybe it could snow where you live on July 1st. I happen to live in the middle of California, and I live in the Central Valley, where in the middle of July, our temperatures in July and July 1st can be easily between 100 and 105 degrees if it's not a total heat wave. So at our place, this is most likely going to be unlikely, anywhere from unlikely to impossible, but hard to say it's impossible because you just never know. So certainly unlikely, and I could probably say just because of where I live, impossible. All right, what are the odds the sun will set today before 11 o'clock p.m.? So the sun will be gone before midnight. I would say that is going to be certain. All right, last time I checked, the sun keeps rising and setting every single day. All right. I, spinning the spinner results in green, and you can see here, it's hard to tell, I know, because black and white, sorry about that. We have green on about half of this spinner. They have red, blue, and the other quarters, and green there. So the chance of it getting green is about half the chance, so that is going to be equally likely as not. And what's the chance of the spinner landing on yellow? That is going to be impossible. Why? Because it's not even an option. There's red, there's blue, there's green. It is impossible. All right, so look at your answers, talk about it with your partners and see what you disagree with, whatever. And you can also invent another situation for each one of the labels for a total of 5 more events. So think of your own things that could happen that could be impossible, certain, unlikely, likely, and share those with a friend. All right, activity number 3 says your teacher will have 2 students play a short game, and when the first person chooses when the first person choose 3 numbers, did they usually win? When the first person when the first person chose 4 numbers, did you expect them to win? Why? So the way this game works is player number 1 in round 1, game 1, is going to choose some numbers. Okay. Now on a regular die, you have numbers 1 through 6. Okay, so let's say player 1 chooses the numbers 1, 2, and 3, okay, as options. So if they roll a die and they get a 1, 2, or 3, they win. If they don't, like they roll a 6, then they lose. Okay, so you do player 1, player 2, and so in this case here, player 1 got to choose 1, 2, and 3, and the winner was player 2. Now, in the next round, the second round, player 2 gets to choose 4 numbers. So player 2 chooses numbers, he's going to choose 2, 3, 5, and 6. Okay, so he gets to choose there. And when they choose, he gets a 2, he's the winner, and winner again. Alright, way to go. Now again, this is chance. The idea is then you go another next round. So player 1 gets to choose some numbers, right? And they could choose numbers 3, 4, and 6. They roll the dice, and they got a 6, and they got a win. So choosing 3, you can still win. Now when they win, they get to then choose 4 more. So maybe they choose 1, 2, 5, and 6, and I got a 2, so they won another game. So right now in terms of wins and losses, it's pretty even there for what's happening. It's not making a big difference whether they choose 4 numbers or 3 numbers. It does though seem that whenever you choose 4 numbers, you always end up with a win so far. The idea here is just to play a little game and roll the dice to see what do you come up with, okay, and how often this happens. This is what we call a chance experiment, like the lesson, and that's because we can't be certain of what's going to happen every time. Okay, so let's do a little chance experiment real quick here before we kind of move on. All right, let's just say I'm going to roll the dice, okay, and I'm going to look for odds 1, 3. We'll do this. We'll do 1 and 3 compared to 2, 4, 5, and 6. And we'll roll the dice 10 times and see what happens. Okay. So if you're guessing the 1 and 3 is going to come up compared to your friend who gets the other ones, let's see who wins the most. You got to pick. You liked 1 and 3 as the best chances. Let's see what happens. Well, there's 1, 2. Boy, you guessed well. 1 and 3. Ah, 6. There's your partner. 6. There's your partner. 1. Man, you're still winning. You're doing well. 2. Okay, tied it up. 3. Man, you're doing great. 4. There's a 6. One more roll. And a 4. Okay, so you won 4 out of the 10 matches compared to your partner, and you got to pick the numbers. Now, you picked pretty well because you got 4 right. Good job. But again, it's chance. If you do this all over again, you might end up with something completely different, and it just wouldn't be the same. That's just how that works there. So if you play that game in class, awesome. The idea with the class is just to experiment with it and see how likely things are to happen, whether you get to pick 3 of the numbers of the die or 4. It kind of doesn't really matter too much, but the more numbers you get to choose, the more likely your choice is going to come up. All right. I'm going to move to the next activity, which is this card sort activity. Now, in the card sort, your teacher's going to give you some cards that describe events. Order the events from least likely to most likely. All right, so here are the first cards. First cards we have here, we have 4 different ones. It says the offspring of 2 fruit flies in a science experiment have a 75% chance of having red eyes. The chance of the first fly to hatch has red eyes. That's 75% chance, right, of having red eyes. Pretty good. 10% of people left-handed. The chance that a randomly chosen person is left-handed, well, 10%. So that's a little less there if we put them in order. The weather report says 20% chance of rain, 20%. So we technically would put that there. Now where I live, I'd move it down lower because our weather people are always wrong. And then half the cards in the deck are red and half black. What's the chance you get a red card? Well, half is going to be how much? 50%, so we put that right there. So in terms of ordering those from least likely to most likely, that's about the order I'd put those in. 10%, 20, 50 to 75%. Now, the next thing your teacher is going to do is hand out to you some more cards. I'll back up a little bit here. And you want to include these then in your order. Now, I don't think I can get them all on one screen here. So we have 2 out of every 5 dentists. 2 out of 5 dentists. A chance that they recommend it, 2 out of 5. Well, 2 out of 5 is like 2/5, which as a decimal is 0.40, and as a percentage is 40%. So we'd put that right there between the weather report and the half of cards, right? The next one says the chance your opponent will play rock first in a game of paper, rock, scissors. Well, how many choices are there? There are 3. So we're talking about a 1 in 3 chance. Now 1 in 3 as a decimal is 0.333 repeating, or about 33%. So we'd probably put that one there, right? Kind of go the order there like that. Okay. Let's see, a pile contains 6 square pattern blocks and you choose 1. The chance of the block you choose has 4 sides of the same length. Well, let's see, this is 6 square pattern blocks, right? They're all squares. So if one's the same length, that's going to be 100% chance because you're talking about picking up a square which has 4 sides. Put it out there. Next, a fishbowl contains 5 balls where each one has an even number from 2 to 10 written on it. The chance that you draw out a ball with a number 3 on it. Okay, so there are 5 balls where each one has an even number from 2 to 10, and you're going to draw one that has a 3 on it. Now, what are the numbers in the ball? 2 to 10, right? And they're even numbers. So the chance that you get a 3 is a 0% chance. It doesn't exist. There is no 3. So that would go before the 10% up there. And finally, oh, we got 2 more here. In general English usage, 4/25 of words begin with the letter T. The chance that a randomly chosen word in a novel begins with the letter T. All right, well, it's 4 out of 25. So if we multiply this by 4, we end up with 16 out of 25, 100. So 16%. So that's going to go over there. 16%. And finally, probability of medical tests has the right result is 0.95, which is about 95%. So we put that down there. Okay. So that's about how I'd add those in there. Again, just trying to get it all in one screenshot for you. And that is the idea. So probability, least likely, drawing an odd number when everything's even, or sorry, that's impossible, all the way up to most likely, drawing a square out of a pile of squares. That's most likely, or certain. So those are the things we're looking at there. So in summary, a chance experiment is something that happens where the outcome is unknown. Unknown outcome happens with chance. For example, if you flip a coin, we don't know if it'll be head or tail. Now, an outcome of a chance experiment is something that can happen when you do a chance experiment. For example, when you flip a coin, the possible outcome is that you get a head. An event is a set of one or more outcomes. So the outcome is what happens, okay? That's what happens. The event is the set of things, okay? So that's how we talk about things. So there you go. So when I do an experiment, I'm going to get an outcome. That's what happened. When I do get lots of outcomes and put them all together, I call that the whole event. Okay? We can describe things as impossible, unlikely, equally likely as not likely, and certain when describing all of these fun events. We're going to pause there and let you work on your homework. We'll come back together and check it in just a minute. All right, here we go, homework time. What's the likelihood that Han makes a free throw basket? Oh, sorry, the likelihood that he makes one is 60%. The likelihood that he makes a 3-point shot is 0.345. Which one is more likely? So for free throws, he's at 60%. But for a 3-point shot, right, he's at 0.345. Okay? So this one, if we think about even like 50% being, right, this one is greater than 50%. And this one is less than 50%, isn't it? Okay, so just looking at where 50's at, 50-50, this one has a greater chance than that one does. You could also look at that number and say, well, let's multiply it by 100 and turn it into a percentage, and you end up with 34.5%. So the one that for sure has a greater likelihood is going to be the free throw one, has a greater likelihood of happening than the 3-point shot. Number 2. Different events have the following likelihoods. Sort them from least to greatest. All right, now we have them in percentage as a kind of ratio thing, 8 out of 10, decimals, fractions. It's probably good to get them all in one form. I'm going to go ahead and turn all these into percentages just so I'm comparing the same thing. So 60% is good. 8 out of 10, well, that's 8 divided by 10, which is 0.80, which is the same as 80%. 0.37, when I multiply it by 100, gives me a percentage, which is going to be 37%. This one is already 20%. And then 5 divided by 6 is going to give me 0.83. So as a percentage, that becomes 83%. So now I have percentages I can compare, and I want to go least to greatest. So my smallest one is here at 20%. Got it. My next smallest, or next largest one I should say, is 37%, which is listed as 0.37. The next one is 60%, which was just plain old 60%, followed by 80, which was 8 out of 10, and last we had 5, 6. So there we are in order from least to greatest. Number 3, there are 25 prime numbers between 1 and 100. There are 46 prime numbers between 1 and 200. Which situation is more likely? All right. What's the chance that a computer produces a random number between 1 and 100 that is prime? Well, there were 25 of those out of 100, right? That's about a fourth, isn't it? Okay, so about 1/4. Over here, a prime between 1 and 200, there were 46 out of 200. Okay, so let's just say I want to compare them with a common kind of denominator base, right? What happens if I multiply this by 2? Then I have 50 out of 200. And now I can compare 50 out of 200 to 46 out of 200 and see that this one definitely has a greater likelihood. That's one way of looking at it there. I could also then look at percentage-wise and know that this is 50% or 25%, and this is going to be less than that. Because again, if this one was 50, if this was 50 out of 200, which you can think about adding 4 more, I'd have to add 4 more in order to get up to that point, which means it's less. So the best one is going to be the prime numbers between 1 and 100 and having that happen. And number 4, okay, we have 4 and 3 cups of cheese, 7 cups of olives, 2 and 5 cups of sausage to make signature pizza. How much of each ingredient is needed to make 10 pizzas? Explain or show. So what we're doing is we're going to say, I know it takes 4 and 3/8 cups to make 1 pizza, but I'm going to multiply that by 10 because now I want to make 10 pizzas. So I do 8 times 4 is 32, right? Multiply there. 32 plus 3 is going to be 35. So I have 35 over 8 times 10. 35 times 10 is 350 over 8. And you can leave it just like that. All right. If you wanted to turn that into a mixed number, you can do that as well. But that's one way of looking at it. Okay. Now for the cup of olives, we have 7/8. Multiply that by 10 pizzas, and you end up with 70 over 8. And that's it for the olives. And for the sausage, we have 2 and 5/8 times 10. 8 times 2 is 16. 16 plus 5 is 21. So 21/8 times 10 is 210 over 8. So those become my solutions as improper fractions. Okay. If I want to write it as a mixed number, this could actually become 43, and you can do 6/8 or you can do 3/4. That's fine. This becomes 8 and 3/4, and this one here becomes 26 and 1/4. All right, just some things you could do as well. So either answer is fine. If you do it as a decimal, this is 43.75, this is 8.75, and this is 26.25 if you're a decimal kind of person. So if you're just checking to see what you got, that's what you got. All right, number 5. Number 5 is a long problem that there's not a lot of space to do on here, but here we go. We have a birdhouse. She wants to build it. We want to find essentially how much wood she needs, which means we want to know basically the surface area of the entire treehouse. We have a top, we have a bottom, which you can't see, we have a front, we have a back, and we have 2 sides that are the same. Again, we're looking for an about, so we don't have to be perfect here. But if we did the top, for example, the top is found by doing what? Multiplying 7.5 times the width here, and the width of the whole thing is 5.5. And that's going to equal, in our case here, 41.25. If I do the bottom is 5.5 times 5.5. Times that together, multiply together, and when we do the bottom, we end up with 30.25. Okay? If I do the front is 5.5, that's the base there, times the height, times 9.25. When you multiply those together, you end up with 50.75. If I do the back is 10.25, or really, it's still 5.5 is the width there, times 10.25. And that's going to equal 56.375. Great long number there. And the side is actually, again, 5.5 times, and we can estimate. We know it goes 9.25 there and 10.25 there. So we just estimated, like, I don't know, you could just say 10. I mean, we're just doing about. I just did 10. Again, is that perfect? No, it's just estimating. We do about 55. But again, there are 2 of those, so we have another 55 for both sides. And then we add all that up. If we add all this up, we end up with 288.75 becomes our solution. 50 point, oh, this is 50.875. Sorry, 875 right there. Sorry about that. So that's what you get. All right. So it's a long process. You can use a calculator, or I used long multiplication. It worked out okay. All right, the next one we're looking at which one we want to know surface area and what do we know volume about. Okay, in order for tiles on the roof of a house, that's a surface area question. How long to clean windows of a greenhouse? That's a surface area question. Soup in a container, that's a volume question. How long to fill a swimming pool? That's a volume question. Paper to go over candy bar wrappers going around something, surface area. Fabric to cover, surface area. And a muffin pan to hold the muffin mix, that's a volume thing. So those are the ones that work for surface area, those are the ones that work for volume. That's it for today. Have a great day. We will see you next time.